So welcome back to week number 2, MATH113, section 7, applications of mathematics in today's world. Okay, this is day number 3. We walked through this class last week with 2 contact sections, 1.5 hours each, but we spent only 75 minutes in each section because we need to give you time to go to the other classes. Now, I just invite you, if you're already here, please make the best use of your mobile devices, your intelligent phone, to log into the UM environment. When you are in the course MATH113, section 7, go to block number 2, which is expressly indicated by week number 2. Okay? In week number 2, you go down the specific bar there, okay? You go down to the specific bar there, and you use the topic online discussion forum for this week. So this is week number 2's block. You go to the tools to track your learning. Here, you come to this forum called the topic online discussion forum 002 for week number 2. You click into this forum. Once you click into this forum, you will be brought to this page, and you can see I sent to you a discussion thread with the name, "What have you learned from the first week of classes?" Okay? So when you click on this particular thread, you will be brought to this page. And on this page, you see that I would like you to talk to the neighbor next to you. Grab anybody who's next to you and spend 1 to 2 minutes talking just to discover, to recall what you have learned from last week's classes, particularly speaking, after we have shown you portions of these 2 videos. And I hope each one of you have already finished watching the 2 videos after classes of last week. But if you have not finished reading them or watching them, it's okay. Just based on your memory and the discussions of 1 to 2 minutes with your fellow students, what do you think you have learned from our first week of classes? And once you got some answer, press the reply button here. There is a reply button here. Press reply. Then you can start typing in your responses in this box, and then you press post the forum. And we're going to do exercise like this at the beginning of each class. I know that at the very beginning it might take 5 to 10 minutes, to rock this up. But as we mature into this course, I could expect that we just take 5 minutes and then get it done. Okay? Other teacher will give a quiz at the beginning of the class to make sure you study it. But my way of doing it is I send a discussion thread. Okay, I invite you to do discussions with your friend first, and then use your mobile devices to type in some quick responses. And from your responses, I could message what you're doing. All right? So after this 5 minutes, we get into the lessons properly. So now you're free to talk to the friends next to you. What do you think we've learned last time? What do you think we've learned last time? Then, blah, you got some idea, and then you start typing in the responses. Okay? This is very important, all right? So feel free to chat with your fellow students and type in something that you believe are what you have picked up, all right? This is for a 5 minutes morning exercise in the class we have, but now it's in the 5 minutes afternoon exercise, all right? Normally, I will arrive here 10 minutes before 2:30, and when I met individual students who are here already, I've already told them the same message. So if you are here early, you should have already done this. If you are here just on time, or a little bit late, it's okay. Just make the best use of this warm-up time. This is kind of warm-up exercise for the class. It's important that you know where we are before we start, okay? What you believe you have learned as of last time. Water droplets yes, right here. Water droplets. That's response. And remember, when you look at the collections of responses at the end of the classes, this is a very good indicator of what you should believe, or what you believe you should have learned, okay? Very important. It takes a while to get the responses. One of the objectives of learning in this course is discussions. Yes, because now it's what you can do is there is some copy, but I made a post it. You believe the same copy of the same slide. That's it. You can add. If you don't need to easy to get something from somewhere. Just a little bit of the comment. If you did already express some of your learning in the public online discussion forum of last week, you do not need to move it here. What you need to do is copy and paste selections of these and add more comments. Okay? You do not need to delete. Don't delete them. Right? These are your records of learning. Alright? So it's very good. Because every week we have different tools for us to keep track of the material belonging to that week. Okay? You see that? We start collecting responses. Math is useful in our life. This is very interesting. Now this is a comment, all right? We welcome different kind of comments. What you should have learned. You've learned math, it's very useful or interesting. That's good. Any other comments? The focus of this week is to help you understand, start understanding calculus, okay? So after this warm-up exercise, we move to the lessons. Okay, let's see. Johnson is the first one. We got another one, David, has already posed something. I've learned that math is more than just calculating. And I've learned that almost everything in nature can be described with math. Math is the language of the universe based on the documentary. That's very good. So we get 2 responses. Okay, let's give it 2 or 3 more minutes. It's very interesting. You get used to this exercise of using the discussion forum to put together one another's ideas, and then from there, we try to give you something very specific towards your understanding in the context of maths. All right? I encourage you to speak your mind, okay? To speak your mind, speak, share, discuss with your fellow students. We have excellent tables here to help you discuss, converse, say something, all right? Let me see if I can help some of you. Make sure you're on the right discussion forum. It's very good. I did something already. Yes. The persons was fine. Yes. Very good. I got a lot of ideas. Still confused. Yes. Yes. Don't worry about grammar. You don't need even a long sentence. Just ideas. Okay? Ideas. Make sure you press close to the forum. Close to the forum. Yes, we got several more by Jeremy. I've learned how mathematics used in our social life and science. Okay, and then Andy said, we learned that we stopped to study mathematics and stopped to learn mathematics. After we finished to watch the video, I discovered that maths is important in our life. It's everything. For example, science and technology. Yes, it's very important. Okay, we got some responses already. And then Iris would say, I found that the power of mathematics is very strong. In every part of daily living, mathematics can be helpful and useful. Particularly have more and more functions in the world, no matter in physics, chemistry, geography, IT. Therefore, I totally consider if they have no mathematics in our life, I cannot imagine that how the world now will become. So, okay, that's very interesting. Okay. Wow, that's good. We're getting responses. You're being very kind. Star would say, after I have watched the movies, I knew there are many things related to mathematics, such as nature, biology, physics, buildings, etc. Okay, that's very good. Now, keep going. Keep typing in your responses. We're moving to day number 2. That's a review, okay? If you look at the white screen, if you look at day number 2, okay? I've given you something very interesting. Let me just enlarge this. Okay. Yes, that's much easier for you to see. Today, in the world of the internet, learning, we have all the knowledge we need if we can have the ability to study. Or better say, if we know how to learn, we have all we need to pick up what we need. For example, a kid in the kindergarten or primary school, if he or she knows how to read, and we can show them, well, go to the education portal, which a lot of the courses there are free of charge, where you can learn calculus there, learn algebra there, learn arithmetic there. Now, in the context of this course, because our focus in for calculus, so I told you sources to learn calculus online with a lot of video, a lot of explanations, a lot of notes. So normally I will seldom write my notes on a whiteboard because a lot of the good notes are already there. What I need to do is to show you the path to read your notes. Whatever notes you want to read, you choose on your own. Okay? Calculus courses from Educational Portal. If you click on this link, you'll be given several courses at different levels. MATH113 Calculus on Education Portal is one of the numerous courses that teach you calculus from Educational Portal. And Educational Portal provides some of the free of charge courses, but some of the dedicated courses with tutorials. You need to pay, for example, I get several tens of US dollars per month, about $20 US per month, and you can get access not to just one course, all the courses. Okay? So then there are universities in the world, big university in the world, like MIT, Massachusetts Institute of Technology. They produced something called Open Courseware about 20 years ago, and now it's getting stronger and stronger. And one of the very famous courses is the calculus course. They have the single variable calculus, multivariable calculus, and I will use this course to help you to understand calculus. Okay? And another very useful course which will teach you not just calculus per se, but the applications of calculus is also coming from MIT's OCW, Open Courseware. It's called Highlights of Calculus. And indeed today we are going to use highlights of calculus to kickstart the learning calculus. Well, another very interesting course is on the highlights of calculus, which also deals with calculus with a focus on applications, also coming from MIT OCW, is called Calculus for Applications. All of these are free of charge. All the excellent sources there with the tools there. Now today, in the 21st century, designed the Open Courseware, which is being offered by the Massachusetts Institute of Technology, it's something called Coursera. Coursera, it's a social entity was so entertaining before, but now it's a profit-making company, but it still is very offer a lot of free of charge courses. What you need to do is to sign in, and then you can register for a course free of charge. But if you want credit from that course, you want a certificate from the course, they will charge you. Okay? They will say that you must finish all the exam homework there, tests there, and examinations there with true authentications of your persons, like your fingerprint, your eyebrow, or something like this, and you can identify it is you who did the exam and you who did the test, and they will issue you a certificate. And now, increasingly, many universities accept these certificates as equivalent to regular courses. So here we have a number of sources that I enumerate for you to learn calculus online. And there are many good professors who produce interesting video to help you to understand calculus. For example, one professor produced zombies in calculus. And how do you make use of the knowledge in calculus to avoid an attack of zombie? You know what a zombie is? Yeah. You know that? Okay. It's very interesting. And then, don't worry much about this. And if you'd like to watch the video last week, 2 classes, you click on the links here, and you will be brought to the YouTube video of our last 2 classes. For example, here it's the second class, the YouTube video of last class. You can always review them, okay? The Academy, that's why I have the cameras there, okay? So, this is just one resource to help you to learn, all right? So remember, let me emphasize one more time. Although you are learning calculus and applications of mathematics in this course, but the purpose of a GE course is to help you to transition from being a taught-to-learn student that you need to help the teacher how to learn, to being a learn-to-learn student. That means you could become your own teacher to help yourself learn. That's why I need to show you the resources instead of just writing everything on the board, okay? So you know the process of learning. You also know the content of learning. All right, having said that, let's move to week number 2. At the beginning of each week, you can see that I've given you the before class activity, the during class activity, the after class activity, and the end of week activity. Okay? So before you come to today's class, you should have preview on those names, particularly with the before class activity. Now, today, we're going to help you to understand calculus. So, I do not know your background, but remember, I do not assume you need a specific background to start learning calculus. Everything you can start from 0 based on your high school math will be good enough. So let's bring you to before class activity. At the before class activity page, you see that I prepared something already for you to follow in every week, okay, before you come to class, be it today or on Friday, okay? You should take a look at the interesting information here. Let me just try to maximize this, okay? Now, we do not need to buy a textbook, but I do use a reference text that I would like you to do some follow-up reading. But I do not force you to read, okay? But if you believe you need the help of a textbook or reference book, this is it. You can get it from the library, textbook section. You can check it out, or you can even buy it in the bookstore. Calculus Early Transcendentals, versions, the 7th editions, with the authors C.H. Edwards and D.E. Penn, produced by Pettis Hall. It's about 300 and something lines, okay? But, as I said, the learnings that comes from this course, I collect the resources from all around the world, particularly from the United States, okay? And particularly from high-end university. And this course, I would use MIT's material, okay? These are very standardized material. So, what I'm going to show you is the MIT's highlight on calculus, which was done by Professor Gilbert Strand. Okay? Professor Gilbert Strand is a very mature, experienced professor. He produced 1, 2, 3, 4, 5 highlight videos to help people understand calculus. And today, we are going to use the first video called the Big Picture of Calculus to help you to understand what calculus is all about. Okay? So you can see that these are the descriptions of what this video is all about. And down here, I've also given you online textbook, which was written by Professor Gilbert, particularly chapter 1. Okay? I'll give you chapter by chapter for the sake of copyright. So the first chapter from this textbook, which was the 1991 versions of the calculus book, it's okay, calculus is several hundred years old. This does not produce any obstacles. It's called Introductions to Calculus, okay? And Professor Gilbert would use different examples to help you understand it. And you can read the whole chapter 1 here by downloading the PDF here. You can read the specific sections here, so you can actually click on those links, and you will have the chapters at your fingertip, okay? Besides the reference text, which is suggested. Now, one of the key things about the reference text is I will assign practice questions from the reference text. That means from this text, I will assign the questions, the homework question that you need to practice, and you also need to submit with your different submissions. You have 3 submissions to do, okay? And each week, I will give you some practice questions. Now remember, you need to name your learning partner by the end of this week. The 2 of you in your pair are responsible for completing the practice question and submitting the questions when it is due to receive the score homework. Okay? That is what is basically needed from you to make sure you do the practice. The calculus is the kind of thing, besides understanding it, you do not practice. It's very hard to apply the basic technique, although we understand that. We have to stop teaching calculating when we need to enable you to start learning math. But to understand the environment of the topic, we need you to do homework a little bit, all right? So after doing this, you understand that you have these sources. And then I have 2 specific names which come from the Khan's Academy. Now, if you do not know what the Khan's Academy is, I tell you that it is originated about 10 years ago, actually less than 10 years ago in the US. It was started out by a guy called Salman Khan, who happened to do some video tutorial for one of his cousins. Very long distance apart. He is in California, his cousin is in Florida, and at one time his cousin needs help of mathematics. And he said, okay, I'll tell you what to do. He took up his computer, write something on the electronic pad, and then send the video of his discussions to his cousins. And later on he discovered that many people like it. And so he started doing e-lessons. And at one point, his e-lessons were so popular that even Bill Gates' daughter, you know who Bill Gates, Microsoft CEO, benefit a lot from Salman Khan's e-lessons. And so Bill Gates said, that's a good thing, I put money into your company. And that is not even a company's one-man job. And today, Khan's Academy become a very substantial entity to help kids from the US and also around the world with their own language to learn different subjects, okay? From primary school to secondary school, even now to higher education. And the 2 topics that I would like you to make the best use of is called Introduction to Limits, okay? And some basics of defensive calculus. Oh, why do we need that? Because if you look at our calendar, okay? To the calendar. The first week is introduction. The second week, this is week number 2. We need to study limit and continuity on the context of calculus. That's the reasons why I provide this link here for you to know how to use the resources here to make sure you understand how to learn the topics. Okay? So it's very important that you preview those resources. Now is the page called before class activity. Okay, before class activity. Right? So definitely there is also a page called during class activity. That's what's happening now. We have the MIT stuff, the 4 important sections for this week. Okay, we will walk you through them. And all of the resources here that you need to learn calculus are included on those pages. For example, in this page, we are going to learn the first lessons on the calculus in lecture 1. It includes introductions to derivatives, examples of derivatives, and derivative as rate of change, as well as limited continuity. And I break this down to the notes on this topic, the notes on this topic. So for each topic, expect a set of minutes you can learn it, and you read the notes. Everything you need to learn is already there. Okay? Not only in a traditional classroom, I'm writing everything on the board and copy it. And you never know the distinctions, the separation of topic, the amount of time. Now I separate them for you. Okay? So you know how to budget the time to learn. That is very important in a mature student. Alright? So having said that, let's get started with calculus. Takes a while. Okay.
Hi, I'm Gilbert Strang, and this is the very first in a series of videos about highlights of calculus. I'm doing these just because I hope they'll be helpful. It seems to me so easy to be lost in the big calculus textbooks and the many problems. And you're in the details, but do you see the big picture? Well, I hope this will help. For me, calculus is about the relation between 2 functions. And one example for those 2 functions, one good example, is function 1, the distance traveled. What you see on a trip meter in a car. And function 2, the one that goes with distance, is speed. How quickly you're going, how fast you're traveling. So that's one pair of functions. Let me give another pair. I could give more and more, but I think if we get these 2 pairs, we can move forward. So in this second pair, height is function 1. How high you've climbed, how if it's a graph, how far the graph goes above the axis. Up, in other words. So that's height, and then the other one tells you how fast you climb. The height tells how far you climbed. It could be a mountain. And then the slope tells you how quickly you're climbing. At each point, are you going nearly straight up, flat, possibly down? So distance and speed, height and slope will serve as good examples to start with. And let me give you some letters, some algebra letters that you might use. Distance, maybe I would call that F of t. So F for how far, or for function, and the idea is that t is the input. It's the time when you're asking for the distance. The output is the distance. Or in the case of height, maybe y of x would be the right one. X is how far you go across. That's the input. And at each x, you have an output y, how far up. So this is F is telling you how far, y is telling you the height of a graph. That's function 1. two examples of function 1. Now, what about slope? Well, luckily, speed and slope start with the same letter, so I'll often use S for the speed or the slope. For the second, it even stands for second function. But let me tell you also the official letters that make the connection between function 2 and function 1. If my function is a function of time, the distance, how far I go, then the speed is, the right letters are D, F, D, T. Everybody uses those letters. So let me say again how to pronounce. D, F, D, T. And that Leibniz came up with that notation, and he just got it right. So, and what would this one be? Well, corresponding to this, it looks the same. Or dy dx. Again, I'll just repeat how to say that. Dy dx. And that is the slope, and we have to understand what those symbols mean. Right now I'm just writing them down as symbols. May I begin with the most important and the simplest example of all? Let me take that case. So the key example here, the one to get completely straight, is the case of constant speed, constant slope. I'll just graph that. So here I'm going to graph. This is shall I make it the speed? Yeah, let's say speed. So time is going along that way, speed is up this way. And I'm going to say, in this first example, that the speed is the same. We're traveling at this constant speed of, let's say, 40. So it stays at the height of 40. I should add units, like miles per hour, or kilometers per hour, or meters per second, or whatever. For now, I'll just write 40. Okay, now if we're traveling at a speed of 40 miles per hour, what's the distance? Well, let me start with the trip meter at 0. So this is time, again, and now this is going to be the distance. After 1 hour, my distance is 40. So if I mark t equal to 1, I've reached 40. That's height 40. At t equal to 2, I've reached 80. At t equal to 1/2, half an hour, I've reached 20. Those points lie on a line. The graph of distance covered when you're just traveling at a steady rate, constant speed, is just a straight line. And now I can make the connection. I've been speaking here about distance and speed. But now let me think of this as the height. 40's that height, 80's that height. And ask about slope. What is slope? So let's just remember, what's the connection here? What's the slope if that's the distance? If I look at my trip meter and I know I'm traveling along at that constant speed, how do I find that speed? Well, it's just slope. It's the distance up, which would be 40 after 1 hour, divided by the distance across, 40 over 1, or 80 over 2. It doesn't matter because we're traveling at constant speed, so the slope, which is up over across, is 40 over 1, 80 20 over a half. But I'll put 80 over 2 as one example. 40. Oh, let me do it. That's arithmetic. Let me do it with algebra. We don't need calculus yet, by the way. Calculus is coming pretty quickly. This is the step we can take. Because the speed is constant, we can just divide the distance by the time to find, and this slope, let me write speed also. Up over across, distance over time, F over T, that gives us S. This is S. Okay, what about calculus goes both ways? We can go both ways here. We already have practically. Here I went in the direction from 1 to 2. Now I want to go in the direction, suppose I know the speed, how do I recover the distance? If I know my speed is 40, and I know I started at 0, what's my distance? Distance, or height, either one. This is now, so these are like both. Now I'm just going the other way. Well, you see how. How do I find F? It's S times T, right? Your algebra automatically says if you see a T there, you can put it there. So it's S times T, it's a straight line. S times T, S times X, Y equal Sx. Let me put another, the same idea with my YX letters. It's that line. In other words, if that one is constant, this one is a straight line. Okay, straightforward, but very, very fundamental. In fact, can I call your attention to something a little more? Suppose I measured between time 2 and time 1. And I measure, so I'm looking between time 2 and time 1, and I look how far I went in that time. What I'm trying to, I'm going to put in another little symbol because it's going to be really worth knowing. It's really the change in F divided by the change in T. I use that letter delta to indicate a difference between, the difference between time 2 and time 1 was 1, and the difference between height 2 and height 1 was 40. You see, I'm looking at this little piece, and of course, the slope is still 40. It's still the slope of that line. Yeah, so that really what I'm measuring in speed there, I don't always have to be starting at T equals 0. And I don't always have to be starting at F equals 0. Oh, let me draw that. Suppose I started at F equals 40, my trip meter happened to start at 40. After an hour, I'd be up to 80. After another hour, I'd be up to 120. Do you see that this starting the trip meter, who cares where the trip meter started? It's the change in the trip meter that tells how long the trip was. Clear? Okay. So that's that example. We come back to it because it's the basic one that where the speed is constant. And even if now I have to move to a changing speed, you have to let me bring calculus into these lectures. Okay, I'm going to draw another picture, and you tell me about let me draw function 1. Another example of function 1. So again, I have time, I have distance, is, I'm going to start at 0, but I'm not going to keep the speed constant. I'm going to start out at a good speed, but I'm going to slow down. You see me slowing down there? I don't mean slowing down with the chalk, I mean slowing down with slope. The slope started out steep. It got, by that point, the slope was 0. What was the car doing here? The car is certainly moving forward because the distance is increasing. Here it's increasing faster. Here it's increasing barely. In other words, we're putting on the brakes. The car is slowing down. We're coming to a red light. And in fact, there's the red light right at that time. Now, just stay with it to think, what would the speed look like for this problem? If that's a picture of the function, just let's get some idea. I'm not going to have a formula yet. I'm not putting on all the details. Well, actually, I don't plan to put in all the details of calculus. Well, every possible step we might take. It's the important ones I'm hoping to show you, and I'm hoping for you to see that they're important. Okay, what is important here is, roughly, what does the graph look like? Well, it started out, the speed, the slope, started out somewhere up there. It started out at a good speed and slowed down. And by this point, let's mark that time here on that graph. Do you see what is the speed at that moment? The speed at that moment is 0. The car has stopped. The speed is decreasing. Let me make it decrease, 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 decrease. And at that moment, the speed is 0, right there. That's that point. See, 2 different pictures, 2 different functions. But same information. So calculus has the job of, given one of those functions, find the other one. Given this function, find that one. This way is called, from function 1 to function 2, that's called differential calculus. Big, impressive word, isn't it? That's function 1 to 2. Finding the speed. Going the other direction is called integral calculus. The step is called integration. When you take the speed over that period of time and you recover the distance. So it's differential calculus in one direction, integral calculus in the other. Now, here's a question. Let me continue that curve a little longer. I got it to the red light. Now imagine that the distance starts going down from that point. What's happening? The distance is decreasing. The car is going backwards. It's going in reverse. The speed, what's the speed? Negative. The speed, because distance is going from higher to lower, that counts for negative speed. The speed curve would be going down here. Do you see that that's a not brilliantly drawn picture, but you're seeing that's the farthest it went. Then the car started backwards, and the speed curve reflected that by going below 0. You see the 2 different curves, but same information. I'm remembering an old movie, I don't know if you saw an old B movie called Ferris Bueller's Day Off. Did you see that? So the kid had borrowed his father's, not borrowed, but lifted his father's good car and drove it a lot, like so, and put on a lot of mileage. The trip meter was way up, and he knew his father was going to notice this. So he had the idea, put the car up on a lift, put it in reverse, and go for a while, and the trip meter would go backwards. I don't know if trip meters do go backwards. It's kind of tough to watch them while going in reverse. But if whoever made the car understood calculus as you do, the speedometer, now that I think of it, speedometers don't have a below zero. They should have. And trip meters should go backwards. I mean, that movie was just like made for a calculus person. Maybe I'm remembering more. I think it didn't work or something. And the kid got mad and kicked the car, and it fell off the lift, went through the glass window. It was, anyway. Calculus would have saved them if only the car had been, or the meters in the car had been made correctly. All right, that's one pair. That's our first real pair in which the speed changes. Okay. I thought in this first video, if you, later, even today, I'll get to a case where we have formulas. That's what calculus moves into. When f of t is given by some formula. Well, here it's given by a formula, s times t. A simple formula. And then, knowing that, we know the speed is s. Later, we got more functions. But let me take an example, just because these pairs of functions are everywhere. What could I take? Maybe height of a person. Height of a person. Okay, so this is now another example, just to get practice in the relation between the height of a person and the rate of change of the height. So this is the height. Maybe I'll call it y, and let me write height of a person. And what is this going to be? What is function 2? Well, slope doesn't seem quite right. The point about function 2 is it tells how fast function 1 changes. It's the rate of change of the height. It's the rate of change. So let me call it S, and it'll be the rate of change. Good if I use those words. Yeah, so I want to think about how we grow, typical person grow. In fact, as I wrote this on the board, I thought of another pair. Can I just say it in words, this other pair, and then I'll come back to this one? Here's another pair. This could be money in a bank. Wealth sounds better. Let's call it wealth. That's zippy. And then what is this one? If this is your wealth, your total assets, what's your worth? This would be the rate of change. How quickly you're saving. S could be for saving. Or if you're down here, S is for spending, right? If S is positive, that means your wealth is increasing, you're saving. Negative S means you're spending, and your wealth goes whatever. Maybe I hope up. Height is mostly up, right? So let me come back to height of a person. Now, and this is time, in years. This is T in years. And this too, of course. Actually, I realize you start at T equals 0, birth. You do start at a certain, actually, what do I know? You don't say tall, you say long, but then as soon as you can stand up, it's tall. So let's say tall. Shall we guess 20 inches? If that's way off, I apologize to everybody. Let me just say 20. 20 inches. Okay. At year 0. Okay. And then, presumably, you grow. Okay, so you grow a little. What are we headed for? About 60, 70 inches or something. Anyway, you grow. Let me put in some, let's say that's 10 years old and here's 20 years old. Okay. So you grow. Maybe you grow faster than that. But let's say you're a healthy person. Okay, up you grow. Okay. And then, at about maybe age 12 or 13, there's a growth spurt. And maybe the point is, how do we see that growth spurt on the two graphs differently? But it's the same growth spurt. Okay, so here your height suddenly jumps up. Oh, I catch up with everyone. And then at about 12 or 13, well then unfortunately it doesn't do that much forever. And it kind of levels off here, levels off, and actually you don't grow a whole lot more. In fact, I think when you get to about, well, whatever, we won't discuss this point. I think if you get too old, you probably lose some. Let's not emphasize that. Okay, so here's the, now what's happening over here? Well, it's the slope of that graph. So the slope might be, this is time 0, but you're growing right away. You don't, the S graph, the rate of growth graph, doesn't start at 0. It starts how fast you're growing, whatever you're growing, whatever that slope is. It's fantastic that when we draw graphs of things, the word slope is suddenly the right word. Okay, so you're growing, maybe at a pretty good rate here. And then let me mark out 10 and 20 years. And okay, you're doing well. Coming along here. And then the growth spurt. Okay, so then suddenly your rate of growth takes off. But it doesn't stay that way, right? Your rate of growth levels off. In fact, levels way off. You come down to here and you probably don't grow a lot. Did you see the two? This was the growth curve. This was the fast growth. But then it stopped. Up here it slowed down. Here it dropped. And if we allow for this person who lived too long, height actually drops. Okay. in which I don't, also, I'm sure people have devised approximate formulas for average growth rates, but you see, it's the idea of the relation between function 1 and function 2 that I'm emphasizing. Now, my last example, let me take one more example. One more example for this first lecture. So let me take a case in which the speed is, so here will be my two, let's use speed, this is distance, this is distance again, and graph 2, as always, will be speed. And I'm going to take a case in which it's given by a formula. I'm going to let the speed be increasing steadily. Okay, so my speed graph this time is going to go up at a constant rate. So this is the speed S, this is the time t, so this would be S equals, S is proportional to t, that's where you get a straight line. S is, let's say, A times t. That A, the physicist, if we were physicists, would say acceleration. You're accelerating. You're keeping your foot on the gas, steadily speeding up, and so then S is proportional to t. Now, think about the distance. What's happening with distance? If this is accelerating, you're going faster and faster, you're covering more and more speed, more and more distance, more and more quickly. If this is slope, the slope is increasing. Look, the graph, let's start the trip meter at 0. So you started with a speed of 0. You were not really increasing distance until you got slightly beyond 0, and then it slightly started to increase. But then it increases faster and faster. Right? Never gets infinitely fast. But it keeps going upwards. And the calculus question would be, can we give a formula, an equation, for the distance? Because in this case, I guess I started with function 2, and therefore it's function 1 that I want to look at. It's always pairs of functions. Okay. Now, so this actually, let's think where this would actually happen. If we were leaning over the Tower of Pisa or whatever, like Galileo, and dropped something, or even just dropped something anywhere, that would be, we drop it at the beginning, it has no speed, but of course instantly picks up speed. The A would have something to do with the gravitational constant for the Earth, whatever, and then maybe, yeah. And what would be the distance? Okay, now can I just mention a small miracle of calculus? A small miracle. I'm going this direction now from speed to distance, so I'm doing integral calculus. And we'll get to that later. In the first lectures, we're almost always going from 1 to 2. But here's a neat fact about going from 2 to 1. That if this is the time t, then of course this height here will be 8, that'll be A times t. And the amazing fact is that this graph tells you the area under this one. Graph 1, function 1, tells you the area under the graph 2. And in this example, with a nice constant acceleration, steady increase in speed, we notice this is a triangle. It has a base of t, it has a height of at, and the area of a triangle, of course. The area, and my point is that the area is function 1, amazing. That's just terrific. Will be the area of this triangle here is 1/2 of the base times the height. That's the area, and calculus will tell us that's function 1. So this function is, this is 1/2 of a times t squared. So there is a function 1, and here is df dt. If I go back to the first letters that I mentioned, if this is my function f, then this is my function that, and notice what kind of a curve that is. Do you recognize that with a square? That tells me it's a parabola. A famous and important curve, and of course it's important because it has such a neat formula. Okay, so we have found the function 1, that we've recovered the information in that lost black box, the distance box, the trip meter, from what we did find in black box 2, the speed, the record of speed. And notice I'm using the speed all the way from here to here. The speed kind of tells me how the distance is piled up. The distance is kind of a running total, where the speed at that moment is an instant thing. Oh, we have to do that in future lectures. The difference between a running total of total distance covered and a speed that's telling me at a moment, at an instant, how distance is changing. The slope at this very point t, that slope is this height, is at. Okay, so there you have the first, well, I'll say the second. The first pair of calculus was this one, f equal st, and its derivative was s. Our second pair is f is this, and will you allow me to write df dt? If f is 1/2 of a t squared, then df dt is a t. You'll see this rule again. The power 2 dropped to a power 1, but the 2 multiplied the thing, so it canceled the half and just left the a. Okay, that's a start on the highlights of calculus. Thanks.
This has been a production of MIT OpenCourseWare and Gilbert Strain. Funding for this video would...
Now, let me give you a small exercise to do, and that will be a pattern of our class. You just spend 37 minutes to watch this video, which is about the introductions of calculus. And Professor Gilbert Strain used a very interesting intuitive method to need you to think about calculus. Okay? He mentions the idea of functions. He mentions the ideas of relationships between two functions. He also mentions constant versus change. Okay? Now, I would like you to go home, rewatch this video as many times as you want, And then I'm going to set up a discussions thread under this week's Topic 19 discussion forum, which is said, what have you learned from this particular lecture? And I would like you to generate at least 2 questions of your own related to your understanding of calculus. Okay? Calculus. What is it all about? And name some of the examples Professor Gilbert-Strand had used. It's not difficult. Constant speed at a specific number of time, you know the distance. Constant rate of growth for a specific number of units, you know how high you become. Okay? And then, what are the cool questions of calculus? Now make sure you contribute your questions right here in the discussion forum. And when we come back on Friday, make sure you bring a notebook with you, big pencils. You're going to do some in-class explorations, okay? And you do it as a tables of members. I will distribute some exercise for you to do, and then try to bring the pictures together, okay? But make the best use of the resources. And where can you find this video? Remember, you are here on this website. This is week number 2. You click the before class link, okay? You will be brought to this page. Click the big picture of calculus. That is the video, okay? You can watch this video as many times as you want, but I do it here because I want to make sure each one of you have watched it at least once, okay? Now you go home, you watch it again, you have certain background of mathematics from your high school, and most of the examples used by Professor Strand in this introductory video are very basic. Now, actually, he solved some of the difficulty by assuming something. And then he brought calculus in. Remember when he brought calculus in? When he used arithmetic, when he used algebra, and then he said, now allow me to bring calculus in. For what reason? Make some good questions. Generate some good questions. Put it in a social discussion forum here. I'm going to generate this for you. Okay? Immediately. And then I'll take attendance first. And you can find the discussion threads right here in the online public discussion forum 002 for week number 2 by 6 o'clock this today. Okay? So let me take attendance first before I let you go. It's important that we step into this step by step, all right? And I have all the resources for you. Ricky, thank you. Johnson, thank you. Alex, Natia, Stella, thank you. Viviana is not here. Okay. Jordan, thank you. Star, thank you. Chaos, thank you. T.I., thank you. Jeremy, thank you. One, thank you. Soup, thank you. Louise, thank you. David, thank you. Jian Chun, thank you. Xian, thank you. Candy, thank you. Mei Ling, thank you. Iris, thank you. Bella, thank you. Cindy, thank you. Vivian, thank you. Patrick, I see you. May Ha, thank you. Mandy, thank you. Okay. Let's do another page. All right, so Joanna, thank you. And then Jeanette, thank you. Long Yi, thank you. Yun Yi, thank you. Michelle, thank you. Jacqueline. Thank you. Lizzie. Thank you. Doris. Thank you. And then Kelvin. Thank you. Jeremy. Thank you. Finally, Andy. Thank you. Any person whose name is not recalled? No? I see you back here on Friday. Bring a notebook with you, a pencil, eraser, okay? And then get ready to use your thinking to work out some practical examples to understand this. Okay? I see you. Remember, come back to the discussion forum here. I'm going to create a discussion thread right now, and then answer your questions. Okay? Yes. This time, we just need one partner first to form a pair. Later on, I will give you a chance to pair two tests. So, one partner first. This is two-person work for the first learning contract. For the second learning contract, it's two pairs work. It's one team. Okay? So you understand? So you need to find at least one, not two. One. Okay? Sorry, I need to tell you. Okay? Thank you. You need to write in English, but you can ask me questions in Cantonese. At least that. Okay? 因為咁你先係要學嘅嘢，你唔明就唔明嗰條問題出嚟啦。即係你一定要諗，你覺得唔明你就係嗰啲，因為如果你唔係咁樣，你係學即係比較深，要俾啲時間我哋 rush 係俾時間你，所以其實你可以寫啲 notes 出嚟，睇完其實睇完你講好多嘢。3條都講係睇完嘅啦，即係我話你而家開始學嘅時候咧，你唔實你如果你咩嘢都唔睇，你就咁睇個片，你就諗究竟佢講呢樣嘢到底關係點嘅咧？佢係我哋去學 calculus 係咩嚟嘅？有冇講過咧？佢用嗰啲 example 嚟講 calculus。咁你做下啲嘢嚟講。唔好講啦，即係其實手快啲啦。咁你可以你咪試咗嘅，你可以試下問第二個嚟睇。咁你應該問到啲更加精妙嘅題。其實呢個 calculus 係好有趣嘅。OK， 唔好介意我打埋呢個先就好，因為我都要做啲基本嘢先。OK， 拜拜。对 ，by this Friday you must name one forward. So that's it for today's MATH113 section 7 for the day number 3 of this semester. Until this Friday, stay tuned.